Tensile test is a very common mechanical test, which takes a test piece and stretches it along its length. It is a uniaxial test, meaning that it applies a load in one direction only, as shown here. During the test machine measures the applied load and the change in length of the test piece. The main output from the tensile test is the stress-strain curve, which describes how much the material we're testing will deform for different levels of applied stress. Watch how the stress-strain curve evolves as we perform a tensile test on our test piece, which in this case is made of steel. The test ends when the material fractures. We can observe that the stress-strain curve is split into two regions, the elastic region, where the curve is linear, and the plastic region. If the applied stress is low and we remain in the elastic region, the original dimensions of the component will be completely recovered when the applied load is removed. For larger stresses that take us into the plastic region, permanent plastic deformation will remain after the applied load is removed. In the elastic region, the stress-strain curve is a straight line for most materials. This means the strain is proportional to the applied stress. Hooke's law gives us the relationship between stress and strain in this linear elastic region. The ratio between stress and strain is Young's modulus, also called the modulus of elasticity, which we denote with the letter E. It has the same units as stress, so psi in US customary units, and pascals in SI units. We can also measure Young's modulus as the gradient of the slope in the elastic region. Young's modulus is essentially a measure of how stiff a material is. The higher the Young's modulus, the stiffer a material, and so the smaller the elastic deformation will be for a given applied load. If we perform tensile tests for a few different materials, we will notice that the slope of the stress-strain curve is different for each of them. Different materials can have vastly different values for Young's modulus.